Chapter 3, Service Calls. This is a cool little chapter. It's definitely a lot of fun. I enjoy it. We really start getting into the nitty-gritty, getting out into the field, what it's going to be like, what you're going to see, what you're going to hear, things of that nature. So we'll discuss all the different stuff related to being out in the field. If you're stuck in a building, like if you're working for $3.99, it's going to be a little bit different because you're going to know the equipment that you're working on a day-to-day basis. This is more or less for individuals that are going to go off on their own, or if you go to another building for the first time, it's going to be set up for that. There may be times if you're working, let's just say, in a hotel, and there's a customer complaining of a heat call or no heat call, or it's no cool call. Well, then this is going to be geared towards that. So everybody can get a little bit out of this chapter. So we're going to identify and explain the three categories of HVACR service, evaluate a problem using the steps in a standard troubleshooting procedure, explain how a technician's appearance and conduct affect customer relations, explain the ways in which service work is documented. So servicing refers to work performed on installed equipment or systems. Generally, if we are going to work on a piece of equipment, that equipment is already in place. If we're going to put that equipment in, we're talking about a replacement or an installation. And so an installation would be putting in a new air conditioning system, a new heating system. Sometimes if we get into refrigeration, we're talking about chillers or refrigerators, freezers, that sort of thing. I do a little bit of light commercial work, and so I work on some flower coolers, so that would be a type of refrigeration. Generally, when we refer to refrigeration, we're referring to anything that's outside of home comfort. So when we're referring to home comfort, we're trying to keep the home at about 70 degrees. When we're talking about refrigeration, we're trying to keep the space, it can be at 60, 50, 40 degrees, or even colder. But, just so you guys know the difference between refrigeration and just air conditioning. They all use the same process, but they're just different terms. A repair, just a problem that a customer may have, no heat, no cool. Maintenance, that's a vital part of doing service. That's your bread and butter when we talk about money that's being brought into the company. Not everybody's equipment is going to break down every year, and so it's hard to know if we're going to get money. Whereas on a maintenance agreement, you're going to be in that home twice a year maintaining that equipment to make sure that it's running. It's sort of like changing the oil in your car. You want to constantly do preventative maintenance on that equipment to ensure the longevity and there's not a breakdown. If all of a sudden you decide that, hey, I'm going to do a cross-country trip and I haven't changed my oil in 30,000 miles, maybe there's going to be a problem. It's the same principle when we're talking about furnaces, or any air conditioners for that matter too. And then there's upgrades. We want to update the system. We want to put in different accessories that the customer may want. Sometimes it's humidifiers, sometimes it's a simple thing like a thermostat. They want to have Wi-Fi connectivity. Other times it can be indoor air quality. We're putting in UV lights. That's a big thing that has come out since coronavirus hit. People are really wanting a good indoor air quality. So they're putting in different types of UV lights. They're putting in better air filtration because they really want their home to be nice and comfortable and clean. So there's three different types of service work. We're talking about repair. Somebody calls and says, hey, my heat's not kicking on. So you go in and you troubleshoot and you find that the blower motor's not working. So we would replace that blower motor, and that'd be considered repair. Maintenance is performed regularly to reduce the likelihood of a breakdown. Like I said, it's like changing the oil in your car. On an AC system, we're checking to make sure that the unit's clean, it's operating, our electrical components are working properly. On a furnace side, we're making sure that our air filter is clean. That's the biggest thing when we're talking about service-wise, we always want to make sure that air cleaner is always clean. If that air filter is not, then we're going to have issues with airflow, which is going to lead to other problems. And so that's always the first thing you check. If somebody says, I have no heat, I have no cool, let's take a look at that air filter. People don't realize that it's been 6 months, it's been a year since that filter's been replaced. There's times where people don't even realize they have a filter. They just think that it's something that gets done when you come in. Well, no. Air filters should be replaced more often. Generally speaking, if we're talking about the 1-inch wide filters that most homes have, those should be replaced every 30 days. We're buying the cheapest air filter. We're not buying that expensive air filter. It restricts airflow, and by restricting airflow, our system isn't going to run properly. So we buy the cheap ones because our system isn't designed for the other ones, and we put those in monthly. All right. And then there's the upgrades. Like I said, humidifiers, UV lights, thermostats, or anything else that they want on there. Troubleshooting. There's a manufacturer's troubleshooting chart. When you get a piece of equipment, you're generally going to have that the manual along with it. Sometimes it will be on site, sometimes it won't. You always want to find that. So your best resource is your phone. You can easily type in the model number, and once you type up the model number, that manual for that piece of equipment should pop up. If it's really ancient, it may not, but most manufacturers are really good with having that available, or there's a third-party site that's got that manual. So when you pull up that service manual, it's going to tell you all the information that you need, how to adjust the system based on like gas pressure or adjusting the airflow, because those are things that we want to do. But secondly, there's going to be a troubleshooting chart. And the troubleshooting chart is just going to be a little indicative of what we have going on. What's the possible cause unit, or what's the problem? Unit operates for excessively long period or continuously. Well, we may have a refrigerant leak. All right, well then how do we fix that? Well, we have to find the leak and add charge. System inadequate to handle load. Replace with a larger system. What that means is that somebody came in there and they didn't put in the right size system. It's not cooling or it's not heating the space, and we have an issue. And so part of the thing of being a good technician is identifying these problems and really sharing that information with the customer and letting the customer decide on how they want to handle and fix the issue. Like one of the things right now, it's like we have a shortage of refrigerant. Number one, if it was R22 is currently phased out. All right, R22 is the type of refrigerant that most older systems run on. Because of that phase out, we have a certain supply of refrigerant that's available to us. As that supply diminishes, we're not going to be able to replenish that. And because of that, we're going to have a higher price tag. So it's the law of supply and demand when we're talking about R22. And so I'm giving you a little bit of info right now for you guys' paper. So we'll talk about the paper a little bit later on today too. Just make sure that you guys know what to do and how to work on that. But R22 is not going to be available soon. As the supply goes down, the price is going to go up. And when a homeowner is told that, hey, I need to fix my system because I'm low on charge and each pound is going to cost, let's say, $300, is it really worth putting in 5 pounds of refrigerant at $1,500 to repair a system versus just a replacement? So there's different factors there to consider when we're talking about different repairs. If it's a very costly repair on a system and the system's really old, it may just be beneficial to replace it. So, and just some other little things through the chart right here. So when we arrive on site, there's going to be just a certain procedure that we have to follow. The first one is we're going to arrive on site and ask them what the problem is. Maybe you took the phone call over the phone You talk to the customer, maybe they weren't clear. Doesn't matter. You arrive to the site and you ask them, hey, can you please tell me about what's going on? All right, let's talk about the problem again. So they're going to go ahead and they're going to explain that problem to you as best they can. Some homeowners aren't knowledgeable and they're just going to tell you it's making a noise. Great, you have to go with that. Other homeowners are going to tell you, oh yeah, my inducer, it's making a loud noise, screeching, blah, blah. Cool. And so it's up to us to figure it out. So we'll go down there, and we're talking about furnaces. You're going to go down there and you're going to investigate. You may hear a screeching noise, you may not, you may hear different issues, but we're going to go through our sequence of operation to figure out what's going on. And we'll talk about sequence of operation a little bit. You're going to test for a suspected cause. You're going to repeat the test until a true cause is determined, and then identify a specific remedy. Okay? So if we go down there and we realize that our inducer is bad, we're going to try to test it, or we're going to see that our inducer is making a noise. Great. We've found that that problem is ongoing. It may repeat itself for us. It may not. Sometimes gremlins disappear when us technicians show up on site, and it's hard for us to repeat that process. So we have to be aware of that, but we're going to do the best we can. Follow proper service procedures designed to maximize system effectiveness, minimizes energy consumption, refrigerant loss, and other waste. So we don't want to just go, really we don't want to just start pumping in gas if we don't know if that's a problem on an air conditioning system. The other thing we don't really want to do is we don't want to be parts changers. We don't want to just keep throwing parts at a machine until it finally works. We want to be able to use our knowledge, our skill set, resources to figure out that, hey, yes, this is the problem. So we have a service manual, like I talked about. It's written by the manufacturer, and it helps diagnose and service malfunctioning systems. It may or may not have troubleshooting charts in it. Usually most of them do. They're going to vary all by different manufacturers to a different degree of what they look like. Avoid a hasty decision and a quick fix, which may lead to callbacks. That's one thing that we don't want in our industry, is we don't want callbacks. Callbacks are when you came to a site and you did a repair, and then the customer calls back stating that the repair didn't work. Sometimes it's going to happen. Sometimes there's another issue with the system we couldn't catch until we made that first repair. So for example, we come to a site and it's a no heat call. We go in there and we see that our air filter is completely plugged up. So we replace the air filter with a new one, it fires up and it runs. Great. Now we say, hey, hallelujah, we're good, we can just leave. Well, not quite. Because that air filter was so plugged up, air was still trying to get through, and so it was bypassing that air filter. The air filter was acting as a restriction, and let's just say they haven't cleaned that filter for 2 years. Well, I still have impurities being sucked into the system because the air filter isn't working. Air takes the path of least resistance. So if I have a crack or something, if that filter's plugging up my airflow and my ductwork, well, it's going to start sucking from that crack because it's got that less impedance. And so now we're sucking in all this dirt and this debris, and it goes up inside the system and it plugs up the evaporator. Well, the evaporator generally sits above the furnace, and it's got a bunch of little fins in there. And what happens if I get a bunch of debris that gets stuck in those fins? Well, now that plugs up and I have no airflow, and my system won't operate. It'll get way too hot and the system will shut down. So I have to make sure that as I'm working on this system, I go through all the steps and I make all my little measurements and tests to verify that everything is running like it should. We also have system controllers that are going to help us make adjustments and tests. These are really nice because they have a little LED light. This board has one right here, and this one's going to give you a little status light or a trouble code. So basically what's going to happen is that light is either going to stay on the entire time or it's going to blink. And depending on how many flashes that you get, that's going to indicate what type of problem we have. Or there is no problem. Maybe it's just running like it's supposed to. So if you pull the panel off to get to the board, somewhere on one of those panels, there should be a sticker. And on that sticker, it's going to tell you how many flashes equal what part of the system or of operation. So if we have a solid light, that may indicate that our system is running fine. But if we get 3 short flashes and 5 long flashes, well, that may mean code 35, and that 35 wouldn't indicate, and it could be a pressure switch fault. Cool. Now we know that we have an issue related to our pressure switch, and we need to figure out what. And knowing the sequence of operation, we're going to be able to address that issue. And so here's just another version of that troubleshooting chart that we really talked about earlier. Just to go quickly over the sequence of operation, if you guys don't already know, I don't know if I have a slide that covers it, but just to make sure, when we're talking about a furnace, there's a general startup procedure before the furnace starts running. And so that sequence of operation is such. It varies from manufacturer to manufacturer slightly on startup. You're on initial startup, when we first turn the power switch on the side of the unit. Each unit has a little light switch, or it should have a little light switch somewhere around it to turn on that system or off. It's there for us technicians to work on the system. So when we turn that switch on for the first time, the blower motor will either turn on or it won't. Different manufacturers have different parameters on that. The reason the blower motor turns on is the board doesn't know if the system was just operating and there was a power failure, and so it may have just been in the middle of a heating cycle and there was just gas or heat inside the heat exchanger, and so it's just going to cool off that heat exchanger first to get everything nice and primed, and then it'll fire up. Other systems, they don't care. So blower motor first turns on or it doesn't. Now getting to the real sequence, the first thing we're going to turn on is the inducer motor. All right, an inducer motor, let me see if I can just pull up a image of a furnace, and then it'll be easier for me to talk about. So what we have here is we've got a furnace. All right, don't be overwhelmed by it too much. This is actually not too complicated. It looks like there's a lot going on, and unfortunately, just because of all the wiring and whatnot, it is, but overall it's real simple. So the first thing we have is we have this furnace inducer right here. Okay, what this guy does is it's going to suck all the gases through a heat exchanger. So when we start our system up, we have these little tubes up at the top right here. All right, this system has 4 of them. They're called little burners or burner tubes. The burners shoot a hot flame into this little tube right here, which is called the heat exchanger. So behind the black horizontal pipe here, we shoot the burner into the heat exchanger. The heat exchanger is sort of an S shape behind here. It comes down into this box area right here, and from the box it's going to go outside through a flue pipe. So the inducer motor, what it's doing is it's sucking all this hot gas through the heat exchanger, making sure that it gets all the way to the bottom, and then it helps pump it outside via the flue pipe. The flue pipe can be either metal or it can be PVC based on the type of system. So this thing is going to first turn on. Once it starts operating, the next step is going to be right over here. We're going to have a hot surface igniter. There may be a pilot that sits there. You have an older system, but most systems nowadays you're going to run into a hot surface igniter. This guy gets really hot. It's going to glow like a bright orange, and what ends up happening is as soon as the gas is released, the flame is going to light. So our hot mix surface igniter is going to warm up. Once it warms up for a certain amount of time, it could be 10 seconds, 15, whatever the manufacturer dictates. This gas valve right here, it's going to energize. It's going to send gas through the black tube. It's going to shoot through into the heat exchanger. It's going to start warming up this heat exchanger, making it nice and hot. Once it gets nice and hot, we're going to turn on our blower motor. Our blower motor is going to turn on, and we're going to start sending air past the heat exchanger, in turn warming up the space. So that's our general sequence of operation for the furnace. There's different little sensors inside here that help you help the board know what's operating, what's not operating. We're not going to go into that, but just so you know, this is what the how a furnace operates. If we get to, let's just say, the inducer motor is running, we hear a little click coming from the board, but our hot surface igniter never turns orange, well then I may have an issue with that hot surface igniter. Maybe it's broken, and I need to replace that. So knowing what my sequence of operation is helps me determine what next step I need to make. All right, my hot surface igniter turns orange, but I get no gas. Well then, I may have an issue with the gas valve, or I may have an issue with the board. So, all different things you guys will learn. So right in here, we've got a, oh, let me go back. Just a plain Jane, old school type of troubleshooting chart. And it's really nice because it's telling you, yes or no questions. Do you have a high voltage to the furnace? Yes. All right, cool. Do you have a good ground to the furnace? Absolutely. Do you have 24 between C and W on the board? No. Well, then I jump over and I just follow my questions until I get to the answer. Okay? So let's just say, do you have 24 volts? No. Is the thermostat calling for heat? Yes. Well, then the thermostat or thermostat wires are faulty. Cool. So I know I need to go and start looking at the thermostat, make sure that it's calling for heat. Identifying the problem, listen to the owner's complaint. The first thing we want to do as technicians is just come in there and just start talking, over the customer. Hey, we're going to do this for you. No. Sit back, listen to what the homeowner has to say. After they're done speaking, then we can interject, or not interject, but talk to the customer and let them know, hey, we're here to help you. We're going to do our best to help, fix this problem, get you running, that sort of thing. Usually we can come in there and give them great news. Sometimes we're going to give them the bad news. Hey, I'm sorry, but you need a new system. Nobody wants to hear that, but you can at least let them know we can repair that for you. We can take care of that today for you, or tomorrow, or whatever the case may be. Associated with the manual and also on the panel is going to be an electrical or a component diagram. That's going to be critical for you guys to know what wire goes where, so you can follow the electrical diagram to figure out what components connected to what and how I need to fix it. Don't make quick decisions. If you're in a rush or in a bind, I would just stay away from just doing a quick fix. It may come back and bite you in the end. There's a difference between a quick fix and a temporary fix. If I have, let's just say, a certain type of part that's going to get the system running until I can get back to the supply house tomorrow, and it's 11 o'clock at night, well, okay, I may hook up that part to make it work. I will never bypass any safeties. Safeties are critical to prevent a system from failure or a fire. So we never want to bypass a safety. We can bypass a safety for testing purposes, but I'm not walking away from that machine with a bypass safety. Understand there's certain things that I can do as a technician to make the system work until I can get the right part, but I always want to make sure that it's done safely. And then we have that status light trouble code chart off to the right. The 1 flash, the 2 flash, the 3 flash, so forth is going to tell you exactly what we have going on.
Okay, this one covers some of the simple error codes that you'll find on Carrier Payne and Bryant furnaces. These are later model furnaces, probably around 2000 and forward to that. I'm not going to give model numbers because there's way too many of them to give. But these are the simple error codes that you would find on these furnaces. Okay, here's a look at the inside of the furnace cover. This covers the entire furnace. Right here is your LED code key. So you pull that cover off, you can look at those keys, and it'll tell you where to look for if there's a problem. Once you got the cover off, you've got these windows. This window on the left is going to show you the blinking code. Now there's two lights in there. Okay, pull the cover off so we get a little better view of these lights. There's actually a total of 4 lights in there. For this video, I'm going to just do simple blinking codes on this. This actually has very complex codes for many things because it's a very complex furnace. But I'll do the simple ones in this video, and I'll have another video that gives more of the complex ones. Okay, that's your indication of first stage heat, everything normal. The light just stays on. Second stage heat, the yellow light goes on. That's that one right up there. Okay, this code is for high limit. It's a 33. There's 3 flashes with each of the 2 lights. It means a limit switch is open, plug filter, plug lower wheel, duct problem, or possibly a rollout switch open from the flame rolling out the front. So that's a high temp limit code. Okay, this code we're reading here is an ignition failure code. It means the burner did not light for whatever reason. Could be the gas off, could be flame rod not sensing, could be hot surface igniter not working. But for whatever reason, it did not sense flame. That's a 34 code, and it's going to try 3 times, and then we'll see what code it goes to, what it goes in hard lockout. Right now it's in soft lockout, and it's retrying to see if it can ignite the furnace. Okay, now this code here is a 14 code. And what that means is it's gone into hard lockout, it could not light the burner. So this is a gas issue. There's either gas not getting there or it's not being sensed. All right, this fault here is a pressure switch problem fault. Now, if the pressure switch doesn't close within a few seconds of the inducer coming on, you're going to get this code. Or if the pressure switch is stuck closed, you'll get this code. This is one of the most common codes we have, and it's usually not a pressure switch problem. It's usually a venting problem, sighting vent, water vent, plugged vent blockages, or condensate blockages, where your condensate drain is plugged. Those are all things that can cause this. The pressure switch could be the problem, but it probably isn't. So that's pressure switch problem. Those are all the simple codes that you'll see on this furnace. It's a fairly long family of furnaces, and they usually use pretty much the same codes for Carrier, Payne, and Bryant. I will get into more complex codes in another video on this one.
All right, so the guy mentioned, showed a different codes for different things. He mentioned a couple things I want to talk about too, and that's so you guys just know of terminology. First is like the soft lockout and the hard lockout. So when a system starts for the first time, it may encounter an issue And so by design, that system is going to, let's just say the flame doesn't kick on for the first time. It could be many reasons. Maybe there's the gas was off, or you bumped something, whatever the case may be. It's going to try to restart. Maybe that first time something just got in the way, and it wasn't able to start. It could be an electrical issue, could be mechanical, who knows. The system's going to try 3 times. So that first time that it retries, or first time it gets that error, it's a soft lockout. Okay, the board's going to know that the furnace didn't fire, something's up, let's try this again. It's going to try this 3 times, okay? Some furnaces, they may just keep trying forever, depending on what the code is, but generally, after about 3 times, we're going to get what's called a hard lockout. That system's going to stop operating completely, and you as a technician are going to be able to come in there, you're going to be able to open up the furnace, and you're going to see this hard lockout code. The first thing you want to do is, when you get to a system and we have an issue, besides checking the air filter, is we're going to see what that code is, okay? As soon as you turn power off to the unit and you turn power back on with these older types of systems, you're going to erase that code and you won't be able to recall it. And so you're starting from scratch. That system may reset when you turn the power off, and it's going to operate like it never had an issue. We don't know what the issue was, and so it may be hard to diagnose. But before we do anything, we're going to see what that hard lockout code is, and that'll help us determine what's going on. He also talked about the pressure switch. What that does is it helps the electrical board know that the inducer motor is running. The board is dumb, okay? It's plain and simple. It only understands electricity going out and electricity coming in. It doesn't know that the inducer motor is running, okay? It knows that it sends a signal to the inducer motor to turn on. There's no high-tech finagled way on this equipment for there to be a signal sent back to the board. So what they do is they use a thing called a pressure switch, and it's off to the side of the unit. So if I try to pull up that furnace again, I think there was the inducer on there. So right over here, this little round body, that's called the pressure switch. And so what ends up happening is, once this motor starts spinning, it starts creating pressure inside the system because we're sucking all this air through these tubes. And this little tube connects back into the port, into the collector box behind here, and it's going to sense that pressure. Once we obtain a certain pressure level, then the board knows that my inducer's running, my vent is completely clear, and I can turn on, or I can engage the next step, which would be turn on my hot surface igniter. If I have a blockage in my piping, let's just say there's water, there's a bird, there's somebody threw rocks in there, whatever the case may be, well, all this, like the piping isn't going to be clear, and my pressure will never increase. And if my pressure never increases, well, guess what? My furnace won't light. So when you go onto a site, we need to make sure that everything is operating like it's supposed to. 8 or 9 times out of 10, it's never the pressure switch that's at fault. It's always there's a blockage or an obstruction, either in the flue or our heat exchanger. For example, a high efficiency system, it has 2 heat exchangers. That second heat exchanger is plugged up or filled up with water. So we have to ensure that we know what's going on and really dial in and figure out, hey, that this is the problem. We don't want to be that parts changing warrior. Hey, let's throw a new pressure switch. It may work, it may not. You also want to throw in one that's identical or very similar to the settings that it's requiring. So just a little tidbit for you guys.
Today we're going to talk about how to read error codes on a furnace. We're going to start off with reading the error code while power is still applied to the furnace, and to do that we're going to look through the visual inspection down here to the flashing 7-segment display, which is going to give us error codes. It's going to start with an E and then 3 numbers following to tell us what the code is. So in this case, we have a E250. So I would simply write down E250 to record that, and then I would go down here to the chart to E250, which tells me I have a open limit switch. At this point, then I would troubleshoot my limit switch. Now, if I forget to check the fault code before I disconnect power, I very simply have to remove the door, then most people use tape. I prefer to use a wire tie to bypass the safety switch on the door. Okay, reapply power, and when you get the small pulse, you simply push the white button and hold it until you get an E. Once you get the E, you release, and then it will start running through the fault codes again.
So right here, this is an example of some of the newer technology that's coming out with furnaces. We've got a digital display. This in particular one has a single digit. Some of the other equipment out there is going to have a double digit. You know, it may tell you E5 or E250 or, you know, whatever the case may be. The display is a little bit larger. So that's really nice because we can recall the codes. So for example, up here where you put this wire tie, every system has a built-in safety. So that safety is the blower door safety switch. What that does is that it's there so that if the homeowner were to open up the door, we're not just going to suck in air through that blower door with it being off because we're bypassing the filter. So we're going to ensure that the door goes back on so the system operates properly. As technicians, we have to sometimes bypass that switch so the system runs and so we can get and test to all of our electrical components. We have our thermostat wire connections down here. We've got all these different plugs, so we need to be able to have access to those. So using a little zip tie like this is a nice little trick to just keep that safety switch in so the unit powers up. If you were to take this door off and you're still trying to look for that trouble code, well, it's going to be like shutting power off to the system. If you don't have the capability of seeing or recalling the code, by pulling that door off, you're going to reset that code. So just keep that in mind. Before you take that door off, look through the peephole, see what kind of code we're getting, whether it's a digital or an LED display. That's going to help you identify what the problem is. So possible cause and suggested remedies. You're going to check the troubleshooting chart for possible causes. You're going to test the components that you need or that need to be tested. If we're doing a preventative maintenance, it's different. We're testing a variety of components, looking for potential failures. But when we have a failure, we're going to really address the issues that are at hand. We're going to test and inspect to determine the actual cause if we can. When we're talking about electrical boards, we don't have the capability to really test them. All right. What it really comes down to is if I have voltage going into a board and I don't have voltage coming out, I usually know that that's the board. I should have a voltage going into the board and I should have a certain voltage going out based on whatever component it's trying to power. And that's really it for troubleshooting. I mean, I wish we could go in there and check every little pin and find the component. Back in the day, technicians used to do that. They used to take a board out, look at the different components, replace the resistor or the capacitor or anything like that. But at this point, we don't. We just take a board, put a new board in. All right. The manual is going to give you a step-by-step procedure to follow. Actual procedures vary. Environmental and monetary impacts of temporary fixes. Yet again, temporary fixes aren't good. If you do get callbacks, or a lot of them, that says a lot about you as a technician. It almost reflects on you negatively. That may cost you your job. A business is in the business of making money. Whether it's a good company or a bad company, doesn't matter. The main objective is to monetize your services. If you're going out multiple times for repair because you're being negligent, well, guess what? That's going to affect the bottom line of that company, and they may not want to keep you around. So we want to be diligent with our repairs, our work, to make sure that we minimize our callbacks. That's going to really, if you get no callbacks or very minimal callbacks, you're a super tech. If you're a super tech in this industry, you're going to be well sought after. And guess what? If you're a well sought after technician, you're going to be compensated very well. So just keep that in mind. If you do have a temporary fix, the customer's going to pay more money. You're going to have refrigerant loss, extra energy consumed by improper system efficiency, all different things that affect the customer, but it will affect you as a technician as well. So keep that in mind. We always want to make sure that we always follow the basic safety guidelines as you work through a service procedure. There's different shortcuts that are out there. There's different tools that are going to help you make your job easier. But whatever it is, we always want to make sure that we're safe going about doing it. It is our job. It's our well-being. If we can't do our job, well, then we can't make money. If we can't make money, well, then we're going to be hurting. So proper tools, gauges, electrical materials, PPE, and other necessary supplies must be used. The company you work for, they're going to provide you with certain tools to do the job, depending on the type of job. There's going to be a requirement for you guys to have some of your own tools, so keep that in mind. Do buy good pieces of equipment, buy good tools. I would really stay away from Harbor Freight. I mean, if you don't have money and you need something to get by, Harbor Freight's perfect for that. But a lot of the tools, they just don't stand up to the test of time. So don't be opposed to spending some money on something that's going to last you for a while. If you're unsure if you're going to be in the industry for a bit, I understand. You know, you can buy something just to get you by in the moment. But if you're looking at a long-term investment, do buy quality products. Customer service. We as technicians, we're going to be interacting with customers, so we have to know how to talk with them and interact. We're not salespeople per se, but we still have to have a certain persona with them. All right, so a successful service technician will know HVACR service and repair work, know how to meet the needs of customers, understand business operations. So if a customer tells you that, hey, our system just, you know, it's not running as cool as it normally should, well, then we're going to listen to that customer's complaint and we're going to try to address it. You know, hey, all right, we're going to go take a look and we're going to make our measurements. Maybe it's not running as cool because it's the thermostat that's not adjusted correctly. All right, and so we need to be able to relay that information. We're not going to just walk in there and be like, ha, dumb, you didn't set your thermostat right, man. No, that's not going to work. You know, we'll come in there politely and address the customer and say, hey, did you know that your thermostat's set to 78 degrees? Oh, really? I didn't know that. Oh, my kid must have done it. There's a proper way of really talking to them and addressing them. It's also, you're the representative for the company that you work for, okay? If you come in there representing Four Seasons, well, you're the face of that company, okay? They don't care who's at the, at headquarters or whoever else is out there available. You're the one representing them when you're wearing that uniform. So make sure that, you interact with them properly and professionally. One of key successful business is a good customer relation. So be that front man, talk to them in a positive nature. Different customers react differently to you. There's certain customers that I joke around with. I always try to be lighthearted, and so they really appreciate that. And above all and anything, I'm always honest. All right, I'm not going to be a sneaky snake and try to finagle a couple extra bucks in there because I'm trying to make a bonus, or no. Just be honest with the customer, and they appreciate that. With the advent of technology, a lot of customers do their research beforehand, and if you try to sleazeball them, they'll catch a whiff of that really quick, and they'll kick you out of there. So just understand that the customer may already know what you're talking about, and they're playing dumb. Our appearance is critical. We want a neat, professional-looking attire. We're going to have a company uniform or a work shirt. Okay, the company may require you to wear jeans, may require you to wear different pants. That all really depends on the company and who you work for, but we just want to make sure that we have a clean appearance. You know, if we go from one job and we go to the next and our shirt's untucked, we'll tuck in our shirt, readjust ourselves for that new customer. The customer knows that we're working, so if we have a bunch of dirt on us, little tidbits of dirt, it's one thing. If I'm covered in head to toe with mud, maybe I need to, readjust myself and put on a new uniform or whatever the case may be. But, we don't want to be doing too much like that. The other thing too is if you don't do it, booties. Customers really respect when you come into their home and you put on booties, all right? We're not going to take our boots off. We've been working out in the hot sun all day, and we have some nasty funk coming from our boots. Last thing we want to do is stink up their home with our stinky feet. So we're going to keep our boots on. It's going to keep our feet safe. And secondly, we don't want to track any type of mud or impurities throughout the home, so we're going to make sure that we wear booties. We also want to make sure we arrive on time, display good work habits, work accurately and efficiently, respect the customer's property, respect company vehicles and equipment. Treat the repair and the equipment and the property as if it was your own, all right? The same level of work that you would do on your own equipment, do the same for the customer. It does go a long way. Inform the customer of different things. Hey, sir, we found that your capacitor is bad. That's just one thing that we need to address. And sometimes in the sequence of operation, we're going to find one failure to the next and the next and the next. We have to fix one before we can get to the second. And so inform the customer of that. We don't want to just come up at the end and be like, hey man, you owe me $1,500. And the customer be like, wait, what? Talk to them, hey, I've got this capacitor. We need to put it in. It's going to be, $500 or whatever the case may be. All right, cool. Well then, let them know, hey, that's the first thing that we need to fix. We may have other issues, so we're just addressing this as they come up. Okay. So when you do arrive to the job site, you want to state your name. Hey, Mr. Jojo, I'm, Tom with Bob's Heating and Cooling. All right, cool. That's it. You don't have to go, give an entire biography on yourself, but just inform them of who you are and what you're there to do. Confirm the equipment problem. Usually, that's just when you first arrive, you ask them, hey, what's going on? Okay, they're going to tell you exactly. Dispatch or whoever's there, they may relay that information to you, they may not, but let's go ahead, let's get this from the source, because maybe somebody fat-fingered something or they didn't put in the right information. You're there for a bad thermostat, and the customer says, no, my thermostat's fine, it's my furnace just, it's on fire. Well, it's a big difference. Be polite, be patient, and then listen to the customer and show interest. Some people, especially elderly, they're going to talk your ear off, all right? They don't have people that are coming in on a day-to-day basis, and so they may be lonely, and they may want to chit-chat with you. Hey, there's nothing wrong with that. Strike up a conversation. As long as you don't have to be somewhere, why not? It makes their day and helps them, helps you look positively on them.
What's up, guys? Happy New Year! New Year's Day. I figured I'd start the year off right with a video for you guys. No service one today. I just want to do a little talk again. Hope you guys aren't getting sick of me talking all the time, but it's really all I have time to do right now. I wanted to just go over maybe how to approach a customer when you're going in for a service call or a repair or whatever, or how to talk to them. because I've noticed over the years that a lot of guys don't know how to talk to a customer, and they just, they don't get the respect from the customer. You need to earn your respect from the customer, and you have to earn their trust. So I'm just kind of going to start from the beginning. What I do and what you should maybe do. I got a bunch of notes here, so I just want to. A lot of guys may know this, but a lot of the beginners may not. And I know some people have trouble talking to people. I do sometimes. I can be really shy at times. Until I get comfortable. But now that I'm older, I can approach customers and things like that a lot better. So I just want to start just right from the beginning, guys. When you pull up, make sure your truck's clean. First impressions mean a lot. Especially if you're doing residential stuff. I don't really do that, but people are going to do that. They're going to even look inside your truck. If they come outside, you don't want crap all over your truck. You don't want to look like a slob. You want your clothes to be decent. I understand at the end of the day, maybe you're dirty. People will get that, but try to be clean and presentable. That's one thing my boss always stresses on us. He wants us looking clean and presentable, because first impressions make a lot. I mean, like I said, you've got your customers that you've had for years. They know you. They don't care what you look like, because you already have their trust. They already know that you're going to go in there and fix their problem. But say this is someone new. I mean, even customers that I've had for a long time, you first thing you do, you go in, you greet them, even shake their hand, introduce yourself, especially if they don't know you. Give them your name. Say I'm Chris from whatever company, and I'm here to check your AC, or you walk in, or your heat, whatever you may be looking at. Don't be intimidated either. A lot of customers can seem overbearing, or you're going to get plenty of customers that are on you guys. They're going to be staring over your shoulder, this and that. That's going to be more with residential, not so much commercial stuff. I know it drives everyone nuts, but some customers are just going to be that way. Just still try to be polite the whole time. Don't be rude. Things like that. So after you do that, you ask them any symptoms they've been having with the system. Ask them any past repairs, any past service. If someone was there recently, say it wasn't the company you're from, if someone else was there, maybe what they found, if they have any job history, if this is an ongoing issue. Other than that, you go look at the unit. You start at the beginning first. I always go, I ask for the thermostat. I'd like to see the inside unit first. I ask where your power is, any breakers, any switches, things like that. Check all the indoor stuff first. Make sure the fan's running. Check for any type of ice. If it's a cooling or refrigeration issue. Obviously if it's heat, make sure the heat's running, but it's probably not running if you're there for a heat call. Then after that, go to your roof or wherever the condensing unit may be, or your furnace, whatever you got going on. Figure it out, diagnose the problem. Then a lot of times, a lot of customers are going to want to know before you make the repair. So go tell them what's going on. Explain it thoroughly. A lot of people are going to have no idea what you're talking about. Some aren't even going to care. They're just going to want it fixed. Say, fix it. I don't care what it costs. I don't care what you have to do. Just do it. But other ones are going to ask you every little minute question about that unit. A lot of people are really curious about what we do and how these units run, because a lot of people find it interesting. So you're going to have to know what you're talking about and be able to explain the system. I mean, I've had customers I've legit had to explain the whole refrigeration cycle to them, and they're fascinated by it. It's either that or they're quizzing me to make sure that I know what I'm talking about, and they don't have an idiot out working on this stuff, okay? Because we all know there's a lot of hacks in this trade, and that's why good guys get sent in to fix problems. I've fixed so many problems from hacks over the years, it's unbelievable. If they say repair, you go and fix the problem. Get your parts, get whatever you gotta do. If it's not a huge thing that's gotta be quoted out, stuff like that. After that, make sure the unit cycles, whether it's on heat, AC, refrigeration, whatever. Make sure it turns off, turns back on again like it's supposed to do. Okay, you just go out, do your write-up, whatever you do. Go back in, talk to the customer again. Explain what you did. Even some customers, because a lot of people have been ripped off over the years, offer to show them the old part that you changed out. Don't throw it away right away, because some people are going to want to see it, believe it or not. They're going to want to know what you did. They may even want to see the new part before. Some people get very, very picky. And after you're done, you thank the customer. Always be polite. Even if they're rude. I've had customers over the years that are just brutal. Over 20 years, there's only been 2 jobs I've walked out on, and that's because the customer was being ridiculous, yelling, swearing, just a complete asshole, okay? I've walked off of 2 jobs in my whole life, out of like, legit thousands of service calls I've done. So, you know, if that's the case, your company or your boss may not be happy with you for doing that. You're gonna have to explain to your boss. I remember when that happened to me a few years ago. My boss wasn't happy with me for doing that. And once I explained to him what happened with the customer and how the customer was acting, he was on my side. And he called the customer and told him that he's like, you're gonna treat my guy Chris with respect. If not, we're never coming back there again. Don't give this guy any shit. He knows what he's doing. Let him do his job. You want your shit fixed, let Chris do it. And after that, the guy left me alone. He's never bothered me since. And it's always nice to have a boss or a manager or someone that's gonna go to bat for you as well. You need that too, because I'm telling you, some of these customers are brutal. Like I said, that's pretty much it, guys. But just after, be able to explain too. Like I've seen guys, you know, I've been working with them. I'm like, okay, you go up and talk to the customer. They're like, okay, yeah, we're done. We need to get signed out. Like you can't do that. People don't want to hear that. You need to explain to them what happened, and they're going to ask you questions, and you need to be able to talk to them. Like, always be thorough, guys, and explain it, so then you get on a personal level with your customers, and then after a while, you're going to walk in, and customers are going to be like, you know, oh, thank God, Chris, you're here. Oh, I'm so glad you're here. They're going to request you from your company. I got plenty of customers that request me to go there. You know what I mean? They only want me there. It's just because you built up a relationship with your customers. I mean, so that's basically it, guys. That's just what I wanted to go over some of that, start the new year off with that. Probably gonna be a lot of...
So that's just a really good video that I like showing you guys, just how to interact with a customer. I mean, there's all kinds of different facets that he really talked about that I found interesting. Showing parts, you know, making sure that the customer understands. If I'm replacing a part, I'm going to show them, hey, this motor is seized up. I'm going to spin the shaft and be like, hey, compare this to the new one. Or, you know, hey, the capacitor is bad. It's supposed to be this, you know, you test it and you show up, you know, that sort of thing. The other thing, too, that's really prevalent now, I don't know how it's going to be when you guys get back into the field, but it's going to be the COVID distancing and wearing a mask. So when I go to a service call, I'm going to show up, and what's going to end up happening is I'm going to have my mask. I'll have it pulled down underneath my chin so they can at least see my face, but afterwards what I'm going to do is I'm going to be, you know, 6, 8, 10 feet away from the door. They see who I am, you know, not just a bandit trying to rob them. I'll put my mask up over the face, and now I'm ready to enter into the home, you know. Not going to pull my mask down or anything like that. People may be sick, you know, different viewpoints on it, whatever the case may be. But I'm trying to, you know, maintain a nice, correct environment, safe environment for them. Service records, those are essential for establishing permanent business. So service records, when you go into a system and you repair it, there's going to be information, vital information that can be stored for future reference. And so that can be something as simple as model serial number and you know, what type of repair you did. It could be a little bit more in depth, what materials you used, if you did certain types of work. Let's just say you tested the hot surface igniter, it passed your test, but it's very close to failing, so you may record that value. There could be all kinds of different reasons, and all that's going to vary depending on company to company, but it's vital to have that way. People can use those service records for sales perspectives. So let's say we have a system that's 17 years old, we're doing preventative maintenance on it. Now all of a sudden it's 20 years old. We notice that, hey, we have a blower motor failure. We can then take that information to the homeowner and be like, hey, you know, over the last 3 years, you've had this work, and this work done. It's totaled up to this. It may be time for a new system. And that's where they may agree with you and be like, hey, okay, let's replace it. And it's nice too, in case something happens to the data plate. This happens a ton, where you can't read the data plate goes missing or gets scratched up or something. Well, what part do we get? Without knowing the model and the serial number for the equipment, we're not going to know what type of part we need to get. So it's really critical if we have that stored off site. We can call our boss or whomever, the parts runner, hey, I need this part, they'll bring it over. All right. So this is a data plate. Okay. I'm going to teach you guys how to read these really quick. They have a lot of useful info on them, and they're critical when we're servicing equipment. So the first thing I'm going to notice right here up at the top, this is a carrier unit. Different manufacturers are going to have multiple brands of equipment. So Carrier makes Bryant, okay? So you can have Carrier and Bryant equipment. If you open up a Bryant system, it may say Carrier in there, and probably will say Carrier in there. American Standard Trade, same exact equipment, different badge on the outside. If you open up an American Standard, it's going to say Trade inside of it, okay? So just be aware of that. So the first thing we see up top is the product number. All right, this is really critical because it's going to give us a little bit of information inside the product number. So this is a 58MXA100. I don't expect you to know this or memorize this, but right here where it says 100 in the product and the model, and Carrier is the only one that really does this dash, the product number and the model number. Usually most manufacturers are just model and series or serial, but you may need that product number too if you're looking for parts. But this 100 right here, this is going to tell you what size BTU the system is, okay? So I know that this is a 100,000 BTU system. If it was a 080, 80,000, or a 060, 60,000, and so forth. If I didn't have that information, I can look at the input here, and I would see it's a 100,000 BTU system. Looking at the serial number is also going to tell you certain information, okay? There's a nomenclature chart that you can pull up on your phone. Let's just say you wanted to know information about this unit. You would go onto your phone and you would type in, let's just say, Carrier serial number. And by doing so, it'll take you to this website. I usually like the first one. It's called building-center.org. It's, let me just pull it up for you guys. So this site is really good, building-center.org. You would just click on this guy. You would scroll down, and then you've got a list of how it's set up here of, oh, no, I don't want to maximize. But if we scroll down, we've got a 3394A. So I would try to find whatever style matches that. So I've got 2 digits followed by a letter, so it's going to be style 1. So I would go down to style 1, and it's going to tell me what exactly is going on. So the week of manufacture is the 1st and 2nd character. Year manufacture is the 3rd and 4th. So without even looking any further, I can tell that this was made during the 33rd week of 1994. All right, so if this is a 1994 system, that's pretty old when we're talking about furnaces. Usually you're looking at about a 20-year lifespan. Sometimes you find them a little bit older, but needless to say, I would consider replacement rather than a major repair if needed. The other thing that I'm starting to get off of this data plate, I've got an input of 100,000 BTUs. I have an output of 93,000. What this means is if I do the math, I have a 93% furnace. What that means is if I have a 90% or greater furnace, I'm going to have to use PVC exhaust and intake tubing. There's moisture that's created through the combustion process of the unit, and that moisture can get inside the PVC pipes, and if it was a metal pipe, it would rust. So if I had a input of 100,000 and I had an output of 80,000, I would have an 80% furnace, and I generally have a 4-inch metal flue pipe sticking out of that, and that's just to carry the exhaust outside. The other information on here, It's also vital too. It's going to tell me my gas pressure, my temperature rise, and so that's basically the temperature going into the furnace and the temperature coming out. So if I have a 70-degree temperature going into the furnace via my return, I should have 100 to 130 degrees coming out of my furnace above the coil, about 12 inches, 18 inches above it if I have it. If I'm outside those parameters, I need to adjust the system. Over here is my static pressure, motor horsepower, amps, that sort of thing. So here's another unit. This is an American Standard, and there it is underneath the Train Company. It's a forced air furnace, model number 100. So I know inside there, guess what? I have an input of 100,000. Here's my serial number. In here, it may not. I don't know how the serial number correlates to the manufacture date of 94. It could be that these two numbers are reversed and we get 94 that way. I don't know, but you would go back to that site and just look up the serial number, and that'll tell you the age. The temp rise on this one's a little bit different, 35 to 65 degrees. Static pressure is going to be the same. That's sort of like our blood pressure for our system. This is generally the average. When we're talking about blood pressure, we're talking about like a 120/80. This is very comparable, you know, to a 0.5. And then it just tells us a little bit of our electricity, you know, and manifold pressure and some other information that we may or may not need. And then here we have an outdoor unit. The outdoor unit, as you can see up here, we're starting to get some fading. This is very common on data plates. If the data plate is facing the sun, it's on a rooftop, this may be completely faded and you can't read a thing. So at that point, you're really guessing. Hopefully you've been in the industry long enough that your knowledge will be able to take over. You'll be able to figure certain things out, and that'll help you along. But as far as getting model, serial number, that sort of thing, there may be some information in another location, maybe internally, that you would use. Other times it's really a guessing game. But on this unit, we've got the serial number again. So using that old serial number chart that we used before, we know that it was made during the 6th week of 1996. We've got our product number, our model number. With the Carrier Bryant units, even though the C and K are sort of fading out, I know that the model product number are very similar. The 38CK is down here, so I can just copy all of this until we get to that 300 mark where they have the dashes versus on the product number versus the model number. Piston size, it's going to tell you what size piston you need. That's a type of metering device for the system. We're going to put that into the evaporator. We know, what it requires based on the system size. It's going to tell us our refrigerant type. We have R22 in this system. And it's going to tell us how much refrigerant is in there. So when we talk about refrigerant in a system, we're talking about the condenser only. So it came pre-charged with 5 pounds. Now 5 pounds may be perfect if I have a 20-foot line set. What the line set is, we're going to connect from the outdoor unit to the indoor unit. The indoor unit is going to sit above or below the furnace, and that unit's going to get really cold. So it's sort of like that heat exchanger we talked about earlier, except it's going to get really cold. All right, we're going to absorb heat via that evaporator. As the warm air gets blown across it, the heat gets absorbed via the refrigerant, gets pumped to the outside, and we're going to get rid of it. What ends up happening is, if our line is extremely long, we may need to add refrigerant. So there's different tests that we do to verify that, but we at least know from a starting perspective, this unit came with 5 pounds of refrigerant. If I were to have a different type of metering device, a TXV, it would be set at 15 degrees. So this is stuff you guys will know by the end of the course. my power supply, it's feeding it 208 to 230, a single phase, 60 hertz. This is very common for residential applications. It's always going to be a 220. 220, 230, the words are used interchangeably, but we know that it's going to have two electrical lines coming into the system. The 60 hertz, that only applies to us here in the United States. If it was European or somewhere else, we would have 50 hertz. We just know that 60 hertz, it can be used inside the US. The max voltage, 253. The minimum voltage, 197. And it's telling us it can be put outside. I hope so. And then volts AC for the compressor. The compressor is also running on 208, 230. Single phase. My run load amps is 20.5 amps, 60 hertz, 115 lock rotor. So if my compressor were to seize up and I were to take my amp measurement, I would read 115 amps. At that point, I know my compressor is shot and I would need to put a brand new compressor in. Here's my fan motor information. Same thing, very similar to the compressor. We then have design test pressure. My high pressure is 300, my low is 150. So if I'm going to test the system pressure after I'm done making all my copper connections, I'm going to fill it with nitrogen to ensure that I don't have any leaks and we have a nice strong connection. I'm not going to exceed 300 psi. So that's it for this data plate. Service estimates best provided by estimation specialist. You may have a sales team or sales representative for your company. They may go out and they may give the repair, so you may not even have to do this, which is really nice. But they're going to know the material costs, labor costs, the service problems. They can judge the time necessary for the repair and can factor in overhead expenses. So there's a lot of things that go into giving off estimates to be accurate. You don't want to underbid a job, but then you also don't want to completely rip somebody off. Account for all material, labor, and overhead costs, and include a margin of profit. So we need to know how much it's going to cost materials and labor, and our overhead. Overhead is going to be insurance, building, payroll, like for staff that are maybe not out in the field, maybe they're people answering the phone, maybe they're the dispatchers, whatever the case may be. That has to be factored in as part of the profits or the pricing for the repair, and that all gets taken into pricing. It's not just, hey, I'm going to show up and this is the cost of the part, I'm going to make a certain percentage. No, we have to know what we really need to be profitable by selling a certain service. There's a certain quality of service that we need to be able to give to the customer, and that's going to reflect on the pricing. It's just not the part. And then we have service contracts. They're going to help and they're going to provide a 24 availability service clause. So if your company does 24-hour service and they have a breakdown at 3 a.m., well, you're going to go out there as a technician to make the repair. There's always a guarantee for the work to be done. Usually it's a 24-hour window to get onto site as well. When we talk about a maintenance contract, there's usually twice a year service. We're going to do the AC system, and then we're going to do the furnace when it's time. Here, we usually don't start doing air conditioning service until we're above 60, 65 degrees, just because of how the refrigerant is. And so that means we're not really going to be doing service on air conditioning systems until end of April, early May. The last couple of years, we went from 50 degrees, all of a sudden we jumped up to 80 in no time. Well, there we go. I mean, we didn't really have too much of a time to do too many service or PMs, and we started hot right out of the gate. So there could be a weekly, monthly, or annual rate associated with these service contracts. They may not cover parts. Most service agreements, they're not going to cover parts, but they may give you a discount. and the technician must explain the terms and benefits to a customer. There may be different tiers for service contracts. It's really all up to the customer to decide what's going to be best for them at what price point. And so this is just a inspection report, which you may or may not have done. So customer name, address, air handler, make, model, serial, condensing. Oh, and you can notice here on here there is no product number. Like I said, Carrier's the only goofy one that does that sort of thing. And then the different measurements that you can take here. If we're working on, let's see. Yeah, so there's no furnace per se on this inspection report. So this would be all something associated with either a heat pump or air conditioning system, because right here it's telling you electric heat, electric heat strip, and so those are only associated with either heat pumps or air conditioners. So, all right, so that is it for today's class.